So in this section about how salts begin to accumulate on the surface of soil shows us that on the on the left-hand side, part A of this figure 9.22, you see that typically when you have some kind of precipitation, normally in a natural condition, that precipitation will move through the soil. It'll percolate through the soil down into the groundwater. Part of that is because of the deep root system that we're seeing, and that deep root system allows the soil, gives the soil a little better health, more organic matter, more macropores, more former root channels that can guide water down to the groundwater. So that's part of the equation. The other part is, of course, soil texture and soil properties. On the other side, B in this graph, we have another kind of situation where we don't have as deep of a penetration of roots of plants. In this case, they're saying, well, they did agriculture here, and the roots of annual crops typically are very shallow compared to perennial crops. So we don't have that depth of rooting that you would find in a perennial crop to allow the water to percolate down into the soil. So the groundwater actually is much higher. So you can see the groundwater level here compared to the groundwater level here. The groundwater level is much higher, and as soon as you get pretty close, as soon as you get this capillary fringe, see that right there? That's not typically not saturated, but it is wet. It's water moving. Again, remember, water moving upward due to the forces of adhesion and cohesion. When we get that capillary fringe near the soil surface, all of a sudden we start having evaporation that's happening off this soil surface. And you can imagine that if we have water existing in this soil, we're going to have dissolving of salts, okay, and moving of salts. So you can think about over here, we're having water move through the soil profile. The salts are dissolving out of the soil, and we're moving that over here and then evaporating. But when we evaporate, we only move water off. We only move pure water off of the soil surface. Everything else that's in that water, salts and other things that are dissolved in that water, are left behind. So on this soil surface right here, you get this accumulation, this salt crust that begins to form on that soil. That's what gives you salinity. That's what gives you a salt problem in your soils. In Montana and Wyoming, there's a huge amount of this kind of problem. Not necessarily in Wyoming, not necessarily because we have shallow-rooted crops, but more because we began furrow irrigation. I'll draw a little furrow here. And when we began furrow irrigation, we ran water down that furrow, and that water obviously percolates through the soil, but it actually, over time, if there's a bunch of farmers doing it in an area, which there are for instance, in Powell, Wyoming, when a bunch of farmers do that in the area, it actually raises the water table. So the water table could have been here. Everyone starts to flood irrigate, and we bring that water table up to here. So we move that water table closer to the surface, causing there to be more water that's evaporating off, leaving behind higher amounts of salts.